recording what's on the Smart Notebook file that you guys can see on my page. Um, okay. I don't know. Tesla, anybody else have the issue where you try to get into a Google Meets and it just doesn't load? Has anybody had that issue? Because Tesla is saying that she's trying to get in, but it just keeps spinning and it's not doing anything. And I don't know how to help her with that. That's why I was late. You were trying to get into PexZip. I saw it on your screen. No. It's okay. No, so yeah. Oh, before. Well, that was because I hadn't logged in yet. So if I'm not logged into Google Meet, then you guys can't get into the Google Meet either because I'm the owner of the Meet. So yeah, that's why it wasn't working before. Okay, let me see really quick. Okay. All right, let's go ahead and we're going to look at the 3-3 notes. I'm going to put the standard form. So this is one that was in our cut and paste that we had done last week. But we hadn't really talked about it yet. We've seen it standard form in order to find intercepts, but we haven't seen standard form where we're actually writing it in standard form. So that's kind of what we're going to talk about today. So I have a little bit of vocab here for us to look at. So you guys have standard form. It looks like this: ax plus by equals c, where c is just a constant or a number without a variable. So these are the parts we're going to write in on our papers. We've seen slope-intercept form already, y equals mx plus b, and we've seen our point slope form as well. Okay. Let's see here. And we'll do some transparent fill here. It's almost like maybe too transparent. I tried that earlier. Oh, it probably won't do it because I didn't close that box in. I don't know. Is that too dark? Can you guys see that? It doesn't look too bad. Let's see if I close that a little bit more. I wonder why that one won't close up. Try it again. Nope. I don't know why that one won't fill, but the other ones did. I got it. I'm going to cheat a little bit. I'm going to do that. Haha, got it. I made it. It's fine. So that way you just kind of know where you're filling in some of those. So then the coefficient, that's just our number that comes before a variable. So A and B are coefficients in standard form. And then I'll do one more here real quick. I'm going to hide that. And I'm going to hide that. And then equivalent, when things are equivalent, it's kind of like they're equal to equations that have the same value when reduced or multiplied. Your guys' all fits on one page or one line. Mine didn't, but that's okay. So I'm going to give you guys a minute to write that in while I figure out. All right, Tesla got in. Woohoo! I know, it's kind of frustrating. So we are just looking at, like I said, the 3-3 notes. It's in page 8 in our note packet for those of us just joining us, because I know it was kind of tricky getting us logged in. Okay, so I'm just gonna really quickly link Braxton. I really wish it would let me reorganize my Google slides so that I could put you guys in not by first name but by last name, because it's harder to do this. Or maybe I need to reorganize this by last name, first name, so that I can just run through my list really quick and do attendance. Connor, Michaela, Michael. Okay, I'm almost there. Mariah, Owen. Ryan, Tesla, Veronica. Wait, I thought I got Mariah. I did. Oh, Wyatt. Veronica. Okay, I was just verifying that everybody was here. I thought so, except for Ariana and Autumn, but I wanted to make sure that I had everybody here. Okay, so just a little bit of vocab. So the first thing we're going to look at then is standard form, how to write it or how it looks. So standard form looks like this: ax plus by equals c. So it says write two equations in standard form that are equivalent to x plus 4y equals 3. So an equivalent equation, and I'm going to write this here. That's really big. I don't need that big of a font. Oh, you know what? I wonder if, I think my Bluetooth might be turned off. Yeah. Oh, that's why that wasn't working earlier. I got to update something. So I'm going to write equation 1. Nope. Nope. Oh my gosh. I can do this. I can do this. Okay, you guys already have that on your paper, so I'm just adding it to mine. So an equivalent equation is literally just something, like we said, that could either be reduced or multiplied. So if I was to write an equivalent equation for this x plus 4y equals 3, then I could just multiply by any number I want. So if I wanted to multiply, I would have to do the whole thing. I could multiply by, I don't know, give me a number. 2. I could multiply everything by 2, and I would just make sure I distribute all the way through, and that would be an equivalent equation. So I'd have 2 times x, so it's just 2x, 2 times 4y, so that would just be 8y, and I'd have to do 2 times 3 as well. These are equivalent equations. It's just a larger version of the numbers that I already have. That's all it is. Could I multiply by something else? Sure, I could take the equation that I have, or I could take the original, the x plus 4y equals 3. Now here's one that we see a lot, equivalent equations. Instead of multiplying by a positive number, I could multiply by a negative. I could multiply by -1, in fact, and that would be equivalent. So it would just be a negative x, or a -1x, and then instead of a plus 4y, we would have a minus 4y, and instead of a positive 3, we would have a -3. There's another example of an equivalent equation. I could multiply by 100. I could multiply by 10. I could multiply by -1/2. So it really doesn't matter what you're multiplying by. They would still be equivalent as long as you do it to every part. Just like when we do our division, we divide all of the problems all the way across. Same deal. Okay. So then it says, then do your my turn, your turn. Oops, what's going on here? 1 and 2. I don't know why that wouldn't let me. I'm having an issue. What is going on? Why is my mouse not working? I don't know what I'm doing. You guys, I don't know what I'm doing.
That's not good.
Yeah,
Congratulations.
I know. I'm right there with all of you. Well, I don't know. Oh, see, it'll highlight a little bit, but it's not doing. I don't know. I wonder if my batteries are starting to wear. Oh, maybe. The batteries are starting to wear out on my mouse. Oh. Try again. Okay, well, see, something's not right. Let me try this. Oh, see that? I'm using my stylus, and that was working, but the mouse wasn't. So I want you guys to try the my turn, your turn. So it says you're going to do your two equations, your equation 1, your equation 2. I'm going to copy that, bring it down here. I'm hearing a lot of silence from the other room from my son, and he's supposed to be on his meet with his teacher right now, and I'm thinking he's probably not. So I gotta go check in on him really quick and make sure he's doing what he's supposed to be doing. See, now it's almost. There we go. All right, now I'm getting this thing to work. Okay, so I'm gonna have you guys. So like we could just multiply that first one by. You can multiply by 2. You can multiply by 10. I mean, whichever. You're just gonna pick some random numbers and multiply by. And then we can check and see if your equations are equivalent. My turn, your turn, I think might be a little trickier to do remotely because I can't just look at your screens and make sure, look at your notes that you're writing on to make sure that they match up. I think here comes my son like running. Yeah, you're supposed to be in your meet. Go. I have ah! It's fine. It's totally fine. Okay. So like in the first one, if we multiplied by 2, you would just multiply everything. So that makes this a negative 4x, this would make this a 2y, and this would make this a negative 12. So just by multiplying all 3 values by 2. If you chose to multiply by 10, I'm just picking a couple of random numbers here. If I multiplied negative 2 times 10, that would be negative 20. I could do 10 times y, which would just be 10y. And I could do 10 times negative 6 would be negative 60. Could have multiplied by a negative number, and that would have worked fine too. Like this first one, on the second my turn, your turn, if I multiplied everything by a negative 1. So if I multiply by a negative 1, a negative times a negative is going to make this a positive x. If I multiply the negative or the 4 times a negative 1, that would make that a minus 4y. And if I multiply my 7 by a negative 1, that's supposed to be a 1. Let's try that again. Negative 1. That's just going to make that a negative 7. So now it makes the leading coefficient, the leading number, a positive, and the other two are negative. Whereas it started as the first one is negative and the other two are positive. So they both mean the same thing. They're equivalent expressions, so it's no big deal. What's another number we can multiply by? Could I do a decimal? Negative 6? Sure. All right, so if I multiply everything by negative 6, so I'm just going to replace those ones with 6s. So now I have a negative 6 times a negative x, so that's going to make that a positive 6x. 4 times negative 6 would make negative 24y. And then 7 times negative 6 would make a negative 42. There you go. That's all it is. Okay. Equivalent equations, not so terrible. Uh-oh. My son is calling. Mom, I need help. Okay. So let's take another look.
After a while, it becomes your new name.
Right. Okay. So let's take a look at the write an equation given 2 points. And we've done this a little bit. We've done it before with 2 points where we find our slope and we just plug it into our point slope form. We're actually going to do the same thing. We're going to find our slope, pick one of the points and plug it into point slope form. And we're going to simplify it and rewrite it into standard form. So basically, we're just going to get x over to the other side. Hold on. I got to take a quick pause because he's clearly stuck on something. I will be right back. Give me 1 second. Being a mom and a teacher is really, really hard. Oh, yeah. Well, and he's just 8, and he's just like trying to work out his Chromebook and everything in his room, and I'm trying to do this in here, and it's like, ah. Okay. Okay, so let's find our slope. So we've done this a few times using our slope formula. Finding the slope, we do our y minus our y and our x minus our x. So what's the y value? What y value do you guys want to use first on here? Oh. I see Ryan's comment there. Anybody have a y value they want to use? Remember, in an equation, you've got each point has an x and a y, an x and a y. So if you want to use your first, negative 1 works. There's the first y value. That's all we're saying when we mean y1. So if we use a negative 1 for our first y value, then we're going to subtract our second y value, which in this case would be a negative 3. And when we do minus a negative, that'll turn this into a plus positive. And then we'll have the same thing on the bottom. We'll do our x value. So our x value would be 3, and then we'll subtract 2. So I have negative 1 minus, well, actually plus 3. So negative 1 plus 3 would be the same as 3 minus 1. So that gives me 2. And then on the bottom, I have 3 minus 2, which is just 1, which really just means our slope is 2. So then it says pick one of the 2 points. So do we want to pick 3, negative 1 or 2, negative 3? Does anybody care? Nah, I'll just pick the first one. They're both pretty close. They're both pretty small values. It doesn't matter. And so then we're going to plug that into our point slope form. So we've done this a few times. Y minus y1 equals m times x minus x1. So we'll do y minus our y value, which is a negative 1. So that's going to, remember, we switched the sign, so we're going to make that positive. So y plus 1 equals our slope. Our slope is 2. And then x minus our x value, which is our 3. So that's the easy part. The last part then is to just put it into standard form. So we're going to do a little bit of work. We're going to t-chart this a little bit. So first things first, I'm going to distribute my 2 into my x minus 3. So that's going to make this y plus 1 equals 2x minus, remember we multiply, so that's going to make that a 6. And I'm going to go ahead and subtract the 1 over to the other side. So I have y equals 2x minus 7. So that's stuff we've already done. We've done all of those steps before. Oh, I see Draven's comment. So Draven, you're good. So if you distributed it and moved you would have had, if you took 2 negative 3, you would have had y plus 3 equals 2 times x minus 2. If you distribute, you would have had y plus 3 equals 2x minus 4. And then when you move your 3 over, you're still going to get y equals 2x minus 7. So your equation would still be the same as ours at this point. And that's kind of the advantage of doing the simplification. The last thing we would do, this is not standard form, this is slope-intercept. We want to get this into standard form, which means that we just need to move the x to the other side. So I'm going to subtract 2x and just bring it over. The only difference between slope-intercept and standard is that the x and the y are on the same side instead of on different sides. There's our equation. So I have negative 2x plus y equals negative 7. There's my standard form. What do we think of standard form? Easy peasy? On the fence right now? Completely lost? Anybody completely lost? We're doing okay? All right, let's try writing it from a graph. So I think that's actually easier because the slope's easier to count than to write your equations out. So write an equation in standard form. So now we're on page 9, using the graph shown. So the same steps are kind of going to apply. We need to find the slope. We need to find our slope. We need to pick a point. We need to plug it in. And then we need to simplify. So it's basically 4 big steps. I'm listening to my son in the other room, and I'm a little lost, but not completely. All right, good. Hey, that's okay, because that was the first time you've done it. So it's okay. Let me see what I got. Okay. So big steps. Big step first is finding our slope. Remember our slope? In a graph, you can do your slope a couple of ways. You could identify your points and then do your slope formula like we did before, or we could do our rise over our run. And in that case, I think it might be easier to do rise over run than it is to do our slope formula. So we can see in this slope, we're going 1, 2, 3. We're going down 3. And then we're going over 1, 2, 3, 4, 5, 6, 7. Yeah. So our slope, ooh, this one's not as pretty, is negative 3 over 7. Ugh. That's okay. We can work it out. We're going to pick a point. Do we want to pick the negative 3, 3, or do we want to pick the 4, 0? I think I'll just pick the 4, 0. I like the 4, 0 because of the 0 in it means I won't have as much stuff to deal with. It doesn't really matter which point you pick. Okay, so now I'm going to plug it in. I'm going to plug it into my y minus y1. So y minus my y value would be 0. That's all awesome. Equals my slope, negative 3/7. And then x minus my x value, which is my 4. And so now I need to simplify this. So I'm just going to kind of t-chart this, work out my order of operations. So y minus 0, well, I'm not subtracting anything. This basically just becomes y. And then I'm going to distribute. So I have negative 3/7 times x. And I have negative 3/7 times a negative 4. So a negative times a negative is going to make a positive. And I'm going to do 3 times 4, which makes 12/7. And I can't actually divide that. So right now, that's my slope-intercept form. It's not very exciting. It's not very friendly looking, but it is my slope-intercept form. My standard form then is just to move over the x. Okay, so I'm going to add 3/7 x to both sides. So I have 3/7x plus y equals 12/7. Now, technically, our definition, oops, I lost it. Our definition does technically say that it's just x and y are on the same side, and our c value is a constant, a number without a variable. Technically, this is correct, but it's not very pretty to look at. Could we write an equivalent equation where maybe we don't have fractions? So what would I have to multiply by to get rid of that fraction, to get rid of dividing by 7? Well, what's the opposite of dividing by 7?
Multiply.
Boom. So if we multiply by 7, making an equivalent equation, so I'm going to multiply everything, just like this is why we did equivalent equations to start with. If I multiply everything by 7, guess what's going to happen to the 7, the dividing by 7 and the multiplying by 7? They're going to cancel out. So I end up with just 3x instead of 3/7 x. My y is just going to multiply by 7, so it's just going to be 7y. And my 12/7, hey, guess what? Here again, the 7 and the 7 are going to cancel out. And is that a much easier looking equation than 3/7 x plus y equals 12/7? I hope so. Are they all going to have fractions? No, absolutely not. In fact, I try to avoid fractions whenever I possibly can, but sometimes it's unavoidable. And in that case, then we'll just try to multiply to get rid of the fraction. You could have multiplied to get rid of the fraction at the very beginning. You could have multiplied it right here to not have to deal with them instead of waiting until the final product, until the final result. So it's just different ways of doing the same thing. Okay, so let's see if we can. Oh, you guys actually have a picture on yours. So on our my turn, your turn, just some more of the same. I'm going to grab my packet here really quick and put that picture on here for number 3. There it is. There, that picture. That's the one I want. Plop that. Whoa, too big. Right into here so that it's a little easier to do. Okay, so let's see here. So number 3, my turn, your turn. Very much. Jaden's on the fence. Okay, but hopefully, you know, as we do these, as we do them more and more, it gets a little bit and a little bit easier. Like, how's that phone going? Listen to some good music? Uh-huh. Okay, so on number 3, let's do another quick one and see if we can do our slope. So who could tell me what your slope will end up being on number 3? You can either do your rise over your run, or you could do your slope formula. You could do your y minus y and x minus x. Anybody have an idea what your slope is? And we'll take a quick break before we finish up the other notes. Everything's going to take a little bit longer because just takes longer on the computer. 7/7. Good. Okay. Rise of 7. Run 1, 2, 3, 4, 5, 6, 7. So 7/7 is our slope, which we could reduce that. That's just 1. So there's our slope. All right. So then what point do we want to use? Do we want to use the -5, 2? Oh, that's not this. Oh, there we go. I was like, wait a second, something doesn't seem right. Did anybody notice that my numbers here and my points here are not the same? Yours are -5, -3, and 2, 4. Huh. There. Let's see. Okay, that one's right. It was just this one. The picture changed and I didn't change the points. Okay, so if you had done your slope formula, you would have had -3 minus 4, which would have made -7, and -5 minus 2, which would also have made -7. A negative over a negative, of course, is a positive. All right, do you want to use the -5, -3, or the positive 2, 4? Anybody care? No? 2, 4. All right. So we're going to use that point and we're going to plug it on in. So I'm going to do my y minus my y value equals my slope. Slope's just a 1. X minus my x value. We can distribute. No fractions. That's good. So I have 1x minus 2. And I'm going to bring my 4 over because I want to get y by itself. -2 plus 4 is 2. Well, hey, look at that. Isn't our slope, can we see that our slope's up 1 over 1, up 1 over 1 in this equation, in this graph? Does it our graph cross at +2? We probably could have gone straight into point slope or slope intercept form, but that's okay. So that's our slope intercept form. We're almost done. Only other thing you got to do is move that 1x over to the other side. So if I t-chart that, or if I subtract my 1x, I just bring it to the other side. So I get -1x plus y equals 2. And there's my standard form. No fractions to deal with, so it's not that terrible. Hopefully.
Is that a negative? Is it a -2 or a -2?
Right. Oh, right here. It should say +2. Because I had a -2. Yeah. Yeah, the marker got a little slipped. All right, let's try one more here. We have 3, 9, and 1, 1. So if I do, so this time it's not on a graph, and I can't even use this graph to plot it because the 9 goes way off the page. So I am going to have to do my y minus my y, and then in this case, my x minus my x. And what's nice about that is that the x and the y are both 1. So it's 9 minus 1 and 3 minus 1. So I end up with 8 over 2, which again is going to give me a nice slope value. 8 divided by 2 does eliminate the oh, I thought I updated that. Sorry, my GoGuardian turned off on me for some reason. All right, so my slope is 4. Which point do you guys want to use? The 3, 9 or the 1, 1?
3, 9.
3, 9? Okay. So if we use our point 3, comma 9, we can plug that right on in. Y minus, remember we're going to do our y value, so y minus 9 equals our slope. So our slope is 4 times x minus 3. So our goal, let's get y by itself and then bring the x on over. Okay, so it's kind of two big steps here. So first thing to get y by itself, we have to actually distribute that 4. So I have 4x minus 4 times 3 gives me 12. And then I got to bring the 9 over. So I end up with 4x minus 3. That's the biggest step. Distribute, move the number over. And then the last step is just to move my 4x. So because it's positive, I need to move it over, make it negative. Negative 4x plus y equals negative 3. It should be recording. Let me see here. Yes. So I'm using Screencastify to record instead of the Pexip record. So you're not going to see it because I'm not recording the Google Meet. I'm recording only what's on my screen on my computer. So that way you guys don't have to worry about, everybody seeing your faces or your screens while I'm doing a recording. Okay, let's take a quick pause here. Get up and stretch because I'm not sure if you've had, basically it's our mask break. I know we're still in the middle of notes, but this is a good place to stop and kind of pause. And unfortunately this part will get recorded because I don't feel like trying to pause it or restart it and then connect the two videos together. So let's take these last couple of notes don't take that long. Like a 5-minute quick break. I'm going to check in on my son, get up, walk around, stretch, so that you're not sitting in front of a screen all day. And then we will be back at 10:25. So give yourself 5 minutes to just move around. And I'm going to check in on my son and make sure he's doing what he's supposed to be doing. And we'll be back in just a minute. Okay? I'll be right back. I know I'm back kind of early. Yes, Draven. Or are you just playing with the hand raise button? I like that. I think that's kind of cool. Has anybody played with the backgrounds yet? You can change your background filter.
I have.
Nice. Oh, nice. Oh. Yeah, it's kind of cool that you can do that now, and you don't have to feel. Oh, Draven left. Not on purpose, I don't think. Okay. Sorry, I'm just checking my emails really quick. Oh, Mr. Volts is still doing morning announcements. I love that. Okay. The one good thing, kind of a good thing, is I don't have a class right away after this. Oh, we go into lunch, don't we? Technically. Oh yeah, after this we have lunch. So you guys have another nice big break. And then I don't have a third hour class, so I have a break till 1 o'clock. Actually till 1:10. I have a long break. So then I can kind of monitor whatever he's doing for the last few minutes anyways. Okay. So I know a couple people are still gonna be kind of popping back in. It's 10:25. I'm gonna go ahead and keep on moving. I think this might be our trivia. Maybe. I think we're ready for trivia. Nice little break. Oh, it is. It's our trivia. All right. Ooh. I know everybody's gonna be coming back and they're like, no, wait, I didn't get to see the trivia. All right, trivia. Anybody? Who was the fairy in Peter Pan?
I do not know.
Tinkerbell.
Tinkerbell. Tinkerbell was our fairy in Peter Pan. Very nice. Okay. Tinkerbell. How is my, by the way, is there a big lag on my computer, or is that just, or is it good? Anybody know?
It's good.
Okay. Like sometimes I look at the Go Guardian and it feels like it's boop, 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 like it's not really moving quickly. And I'm like, okay. Ooh, I have no idea. What is the official language of Papua New Guinea? I have no idea. This is not me who writes all of these, so it's been since last year since I've seen this slide. And who knows, maybe I wasn't. I don't know. Anybody have a guess as to a language that they might say over there? Look at what it's around it. So Papua New Guinea is this dark orange one. There's Indonesia. But what?
Hindi.
Say it again?
I said Hindi.
Hindi? It's a good
I'm
guess.
not sure though. Hinduese.
I'm gonna take one guess though. What are they right next to?
The corner of the world.
They're next to the corner of the world. What's this big continent right here? Can you guys see it?
Australian.
Australia. What do they speak in Australia?
Guadalupe.
Australia.
I don't know.
African.
They speak English.
Australian.
You're naughty.
They speak. Hey, Draven, can you mute? Thank you. Yeah, they speak English over there. Australia speaks, they don't have, Australian is not a language. English is the language in Australia. They were conquered by the British, just like a lot of other parts of the world. So yeah, they speak English over there. Oh, what was the first American city to host the Summer Olympics? I'm going to take a guess at this because of this that I see in the background. What city has that big?
St. Louis.
That's my guess. I don't know that for sure, but that's my guess would be St. Louis because of the arch there. And let's see here. You are right. Very nice. St. Louis, first city to host the Summer Olympics. Oh, we got another one. Ooh, how many red stripes are there on the American flag? I know how many there are total.
6.
6? Anybody else? Yeah, how many red stripes are there?
Yeah,
6?
6.
There are 7. I was like, I know it adds up to 13 because there are 13 stripes. But I was like, I don't know, is the red the 7 or is the blue or the white the 7? It's the red is the 7. 7 red stripes. I don't remember. I know the 13 stripes stands for the 13 colonies. But I don't remember what this, like there's another special thing that I think the red counts for something and the white counts for something, but I don't remember what.
Apparently, like the red's the blood and the white's the bandages.
That could be.
The red's the blood, and I think the white is meant for like the prosperity of the people and
Okay.
stuff like that. And I know the white's for like freedom.
Yeah, I didn't know that. Thank you for teaching me something, guys.
Entire thing for American.
Yeah. Okay, so we got a couple more problems here. We're going to complete an equation in standard form. This doesn't come up very often. I don't even think I put one like this on the test. It's really just kind of expanding your brain a little bit. So I'm going to run through these ones kind of quick. There's like 2 problems on the homework, I think, and that's it. Like, it's not that big of a deal. So it says find the missing coefficient in the equation. So we're trying to figure out, in this first equation, we're trying to figure out what b equals. And we have the point -1, 1 was given to us as well. So what we're going to do, remember, every coordinate has an x value and a y value. It doesn't have a b in here, but it has an x and a y. So if we look in this equation, there's an x value and a y value. We just have to figure out what b is. So what we can do is we can just plug in to our equation. I'll plug in -1 for x. I'll plug in +1 for y. And we're basically just going to solve this and figure out what b equals. So if I do -4 times -1, that'll make +4. I'll have 1b or just b equals 7. There we go. Thank you. All right, so then we'll just subtract 4, and we end up seeing that b is equal to 7 minus 4. B is 3. Boom. So there's the first one. And then it's got this extra line, and it's saying just rewrite the equation with the 3 in it instead of the b in it. So I had the -4x, and now instead of by, we're just going to say 3y equals 7. And that's what they're looking for. What is it when all of the numbers are there for the standard form? That's it. That's all it really is. It's just plug the numbers in, figure it out, and then rewrite it. So same thing here on this one. Our x is 10 and our y is -3. We're going to try and figure out what that number should be in front of a. So I have a times x, so x is 10, plus 5 times y is -3, equals 15. So this time we actually have something. We have an a times 10, or a 10a. 5 times negative 3 would be a minus 15, equals a 15. And if I t-chart this, I'm going to add my 15 over to the other side of the equation. So I end up with 10a equals 30. And if I divide, if I want to get a by itself, I'm going to divide by 10. Hey, what's a going to equal on this one? 30 divided by 10, I'm just going to get 3 again. So it doesn't always work like that you get the same number, but in this case it did. So then it says write it in standard form. So instead of saying ax, we're just going to say 3x. And then we have plus 5y equals 15. So we're just kind of putting it back into its standard form. That's all it's asking you to do. So just to do a couple more of those real quick, doing our my turn, your turn, kind of the same deal. Let me move that out of the way. So I have 8x plus by equals 4, and I've got the point negative 5, 4. So again, remembering that here's our x, here's our y, and we're just going to plug it on in. So I have 8, and I'm going to plug in x. X is negative 5. B times y is 4, equals 4. So I'm going to multiply those. So I have 8 times negative 5, which would make a negative 40. B times 4 is just going to make 4b equals 4. I want to t-chart this. So I'm going to add my 40 to the other side. So I get 4b equals 44. And so then I'll divide, and I end up getting b is just 11. So then to rewrite the equation, we'll do 8x plus, instead of by, we're going to write 11y. So that's the only thing that changes, is that we just figured out that the 11 goes there instead of a b. That's all we're doing. And like I said, they don't come up very often where we need to figure this kind of stuff out, but sometimes we do. And so that's kind of why we're showing you guys these ones. So the last one here, ax minus 4y equals negative 1. So a, we don't know it. X we can see is 6 minus 4. The y value is 1 equals negative 1. So really that's saying 6a, 4 times 1 is 4, equals negative 1. I'll add my 4 over. Negative 1 plus 4 would make 3. And then I need to divide to get a by itself. So I have 3 over 6, which you could reduce to just a half. So we're going to plug that into the a value. A half x minus 4y equals negative 1. If you were to leave it as 3 over 6 instead of 1 over 2, that's fine. I got a message here. Let me see what I've got going on. Okay.
Can I see A&B? Is that connection so I can get to see it?
Oh yeah, sure. You're talking about yeah. Okay, got it. I'm gonna move that up. There you go. So how do we feel about those ones? Do you like those ones more or less than the whole standard form equation stuff? More. I think they're not bad. Like, it's nice that they're already in standard form, so you don't have to try and put them in standard form. But yeah, they can be, especially if you start getting any fractions or decimals, they get a little crazy looking. But most of the time, I try to keep them pretty simple. So yeah.
this schedule, do we go to lunch like right after?
Mm-hmm. Yep, so you have lunch a little early.
And then we go to third hour?
Yes, so that won't
okay.
start until, I'm trying to think. Third hour does not start until 11:40.
Okay, and then 11:40 till
Whatever, 80 minutes.
like 1 o'clock?
Yeah, I think that's right.
Whatever.
Yeah, and I do have it posted on the stream. Here, I'll put this over here. So this is on Google Classroom too. So you got that. You can see
I took
that.
a picture. Yeah, I took a picture and it's on my at it, and I was like, I wasn't sure if it was different.
Perfect.
Now, but okay, thank you.
Oh, okay. Did you guys see the TikTok video that I posted on there? Let me see. It's Mr. G.
Nope.
No, it was totally relevant, so I had to.
I don't watch TikTok.
Slope is rise over. Anybody?
Run.
I thought it was funny. Right? It's totally relevant too. We're doing that right now. Anyways, okay. Let me put that back over there. I don't know if there we go. Okay. All right. So let's go ahead and really quick. We have two on the back page, page 10. Looking at a multi-step problem. So more standard form. T-shirts at a flea market cost $4.50 each. Pants cost $6 each. You have brought $108 with you to spend on shirts and pants. So we want to describe our variables. So it's just a word problem. I thought you did get 5 and 6. All right, I will go back in just a little bit, Draven, and we can go back and get those. Otherwise, I will post the notes that we're writing on Google Classroom as well. Okay. All right. So define your variables and write an equation describing your possible values. So do we want to just use X and Y? You guys okay with that? Yeah. Heads nodding. No heads nodding. Yeah.
Yeah, it's
Okay. So with this, we're saying now this is the only time that it's kind of weird because we're so used to with our variables, you know, it says that is a function of something something. So the function and then whatever comes after that tells you the x value, and what came before the word function tells you your y value. In this problem, when we look at it, it says to write it in standard form that models the possible combinations of t-shirts and pants you can buy. So what this is, it doesn't say function this time, but it's really just telling you that you're going to have one of your variables is going to be your number of t-shirts. And I actually like standard form when we're doing this better because it's actually faster. So it says we have t-shirts and pants. That's really what we're trying to figure out. Those are our two values. So then when it says, when I go up here and look, it told me some information about your t-shirts. T-shirts at a flea market cost $4.50 each. So that's going to be my t-shirts. That's going to be what I'm going to put in my equation. So $4.50 for my t-shirts, the X, plus, and we have pants. Pants are the $6. So plus 6Y equals, well, how much money do we have all together? We've got 108. So it says we're supposed to graph this equation. Well, there's several ways we can graph an equation. We've done that a lot from last chapter. So this one, since this is my X would be my t-shirts. I'm just going to label this. And this is going to be my number of pants because that's my Y-axis. So if I want to graph this, so I did. Oh, look at that. It said label the X and Y axis. I did that before I even realized it. I'm going to try and clean that up a little bit. Pants. There. Just because it was kind of hard to read. There. Okay. So how could I graph this? Well, this is something you guys did also with that cut and paste, was trying to figure out what are your intercepts. Remember where we were just covering it up and then finding our x-intercept and covering it up and finding our y-intercept? So if I wanted to find my x-intercept, I could just take 450x and set it equal to the 108. The y basically just disappears on the intercept. And same thing, I could take my 6y and set it equal to 108, and that would give me my y value where it crosses the y-axis. So if I wanted to solve that, 450 equals 108, I'm just going to take my 108 and divide by my 450. And I'm going to get 24. So my x-intercept is going to be 24. So if I only wanted shirts, I would buy 24 shirts and that would be it. If I wanted to get my y value.
Well, I'm done to 11.
Okay. My y value, I would get 18. So if I only wanted to buy pants, I would buy 18 pairs of pants and no shirts. That's a lot of pants. So then I'm just going to grab a line and I'm going to connect them. From here, I'm going to use a nice straight line. The straighter your line, the easier this next part's going to be. So the next thing is, what are 3 more combinations of shirts and pants that we could possibly, come on, there we go, shirts and pants that we could possibly buy? So what we're trying to figure out is there anywhere on this graph where we can see that it definitely goes right through the XY value? Does this go right through the line, cross right through the center of that point? Nope. That crosses kind of halfway.
But you can buy 12 shirts or 12 pants and
8 shirts.
8 shirts and boom.
Boom, there's one. So we could buy 12 pants, 8 shirts. Or I'm going to write this as 8 shirts, 12 pants. Only reason I'm going to do that is because then I could just write it as a coordinate, 8, 12, and it's the same thing. So it's just showing a different way to write that. Are there any others? Looks like right there.
16.
Yeah. I could buy 16 shirts and 6 pants. Or you could write that as 16, 6, if I can write that. It doesn't look like there's another one, but we could maybe go, what if I did 12 shirts? What number would I have for the pants? What do you think? What number would be right here in the middle? Probably 9. And you could actually end up then getting a big combination of a whole bunch of other ones. If I did 20 shirts, I could probably get 3 pairs of pants. If I did 4 shirts, I could get 15 pairs of pants. Yeah, so you have a lot of different little ones in between here. And that's because if we actually looked at our rise and our run, our slope would be able to kind of simplify a little bit. So like right now, our rise is, it looks like 3 and our run 1, 2, 3, 4, except that we're counting by 2s on this. So this is 2, 4, 6, a rise of 6, and a run of 2, 4, 6, 8, 10, which would then reduce to a rise of 3 over 5. And that's kind of a way we could look at our slope here. So it's kind of a weird one. All right, the last little bit is actually the easiest thing. And I don't have any my turn, your turn on the word problems. I know you guys are upset about that. I apologize. Last little thing then. Really, is our vertical and horizontal lines. And I know we only have like 3 minutes here. So vertical or horizontal line has a slope of 0 and is drawn through the y-axis. So here's our horizontal line. And a vertical line has an undefined slope and is drawn through your x-axis. So remember that if your line, this is our x equals something, and our horizontal line, because it's going through the y-axis, is a y equals something. So if I have a point, a coordinate, and I want to know what's the vertical line and what's the horizontal line, well, guess what? If I was to draw a point, let's see, if I went -5, -3, and I wanted a vertical line through that point, well, I would be going through the X part or the Y part of that vertical line. I'd probably go through the X part. And my X part would just be -5. Boom, done. If I wanted a horizontal line through that same point, it would go through the y-axis, so we would just need the y value. Boom, done. There's your lines. -5 for the x and -3 for the y. Oh, gotcha. So same thing here. If I was just kind of estimating 2, 7, if that was my coordinate, if I wanted the vertical line through 2, 7, then for my vertical line, I would just go through the x value, x equals 2. If I wanted the horizontal line, I would have to cross through the y value, and there would be my answer. How do you guys like vertical and horizontal lines? Are those ones super easy? And that's it. There's the last of the notes. I keep thinking that I'm done at 11, not 10:50. That's throwing me off so bad. So clearly